Hello, welcome to the audio evolution talk. Today we're going to talk about Kubernetes CLI for developers. My name is Elson Yun, and I've got a co-speaker with me, Thomas Carl, with me. We'll be talking about this new changes on the CLI. Okay, today's agendas will be just talking about what is audio to start with, to level set on what the CLI actually does, and then we'll talk about the tab review on the audio evolution, basically the new changes that we're doing on audio, and then we'll talk about how to customize and build and run your components. And component, I would discuss a little bit more on what that is. And then we'll do a demo on that to spice it up a little bit. And then we'll talk about the future plans for other changes that we're going to make. Okay, so what is audio? Audio is actually a developer CLI that will help you to build and run your applications on OpenShift. Audio today, this is just for OpenShift, and the changes that we're making is making it a little bit more generic. So audio has got something called the component. Components are basically defining how the build and run of your application is. And it depends, for example, the images used for your runtime, and it defines the commands that's used for the builds as well. Basically, making all the build and run components, storing within the components inside audio. That makes you, when you're doing as an application developers, you don't have to worry about how am I going to build the application, how am I going to run the applications. And all I need to do is to provide the applications and focus on your source code and then develop your applications in place. And you don't have to understand how you can actually deploy it to Kubernetes. Audio is going to handle all of those for you. Audio can also define multiple, a notion called applications, that you can actually define multiple components in there so that you can have multiple services linked together to become a much bigger applications. Audio itself is actually an open source project, so you can actually find the source from the repo that's listed in there. Okay, so let's talk about what the tab review of audio does. So as I mentioned before, audio is working on OpenShift only at the beginning. So we are making it kube generic. We actually want the audio CLI to become the Kubernetes CLIs for developers. So what we are doing is we are removing the dependencies of the OpenShift resources, for example, image streams, OC client, and the routes as well, to make it running in any Kubernetes that you have. The other thing that we do is to improve the inner loop experiences. Basically, we're trying to minimize the time between you're modifying the code until you can actually see the changes to take place. By doing that, we are actually injecting different commands into the dev file itself to help you to do development. And then one other things that we have to do is we are actually moving the definition of the components into a more generic format. This shape file format, for which is used by the Eclipse shape project as well. We want to make it to be able to reuse across different components or different systems, so that people can actually do one development of the dev file and then can share across to it. That basically means you can actually bring the build and run information across to different type of environments, and you can build it using audio, or you can build it using some other systems like Eclipse J. Okay, so let's go through the commands that we are supporting for the tab preview. For audio, for the dev file usages, basically the usage flow, if you happens to be familiar with the existing audio, the usage flow is pretty much the same as before. So we try to minimize the changes that is done, and so we have the same experience across the existing audio and also the dev file type of experience as well. So first commands that we are supporting is catalog. Catalog is providing a listing of the components, basically knowing which framework that you have. Some examples of the components can be Node.js applications, or can be Spring applications. So you can actually tell audio what type of application that you have, so that we can actually do the proper build for you. And then the other is the actual create component. This is where the actual linkage is in. Catalog provides you the list of components that's available. Create component allows you to link your particular project to that particular to link your application to that particular component to do the build. And then you can also have the URL command that allows you to expose the URL of your applications, so that you can actually access and test your applications on. We can also do a push as well. That's where the actual build and run of the application occurs. That's where the main actions are coming from. And then we also have the watch commands that allows you to basically listen to the tree of the source tree of your changes. Whenever there's a changes, it will automatically kick off a audio push and do a build and run for the changes to take place. The last but not least, we're also providing a delete function for doing the cleanup. Thomas will be doing a demo on the entire flow of that. He will go through these into more details. But one thing to note that for audio, for the tab review, currently all the dev file functions is actually hiding behind the experimental flag. So in order for you to use the dev file functions, you need to turn on the preferences on audio with the experimental flag turned to true. Then you will be able to use all these functions. Cool. So I talk about the customizing the build and run components, because when you're working with a particular application, it may be a Node application, or it may be a Spring application, but there's something special about your application that needs to be built and run slightly differently. Maybe you need to pull down different dependencies on your runtime container or something like that. Then customizing build and run allows an easy way for you to basically override the default behavior, the build and run behavior from the original dev file that comes with it. So so the dev file itself is actually a format, a standardized format. You can actually see the link from there. As dev file format, you can actually see a schema from there as well. But then during the component creation, what we do is, when we do a component creation, we'll go to our repository of the dev file registry, and basically download the specific dev file that's applicable for the component that you have selected, and put it to the root of the project. So basically what that means is the build and run information is actually storing within your project. You can actually, in case you do want to customize your build, you can actually go to and open up that file YAML, and you can actually modify that so that you can change the way that the build and run goes. So here is an example of the dev file in case you're interested in it. So you can see that in the dev file, you will typically have the sessions of the Docker images in there. For example, these are the two samples that we provide as part of the tab review on our default dev file repository. So the first one is Spring one, which contains the first one and the second one is using a different model. Basically, the first one is using a separate build and run containers. So your run container can be runtime container can be very close to what you do on production. The second one is an open library samples, for which you can see is actually using the same Docker images for both the build and run. So that means you can have a combined container for it. But if you take a look at the dev file, basically what it allows you to do is to define the containers for your build and run, and then the associated commands. For example, if I'm doing a build, this is the command that I'm running within the containers to execute the build. So by knowing this dev file, opening this up, and you can actually modify it, so you can actually modify how your application behaves in the runtime. Okay, so without further ado, I will pass on to Thomas to do a demo on that, so that you can actually see it in live in action.
So hi everyone. So I will show you a quick demo how you can do a quick how quickly you can develop application directly on the cluster. So I will be showing you this using web application. It's two-tier web application. It's here in this window. I have a simple Java application using Spring Boot framework, and here in the second tab, it's my front end, and that one is Node.js application. It's using Nuxt.js framework. So as I said, I will show you how quickly you can develop and work with application. And the thing that I would like you to notice here is that how quickly and fast you can see the changes in the cluster once the application is deployed. So let me, as I also mentioned, all the functionalities that I will be demoing is currently hidden under the experimental flag. So in order to use this in current version of ODO, you need to do first ODO preference set experimental true. I've already done that, but just showing in here. So yeah. Now let's start actually doing something interesting. I will first create a project. So I will do ODO project create. I will call it demo. And once it's done, we can start. So ODO uses the components. Components are basically microservices. So multiple components are creating your application. Each component has a type that is basically a language, a programming language, or the framework. So in ODO, you can use catalog command, these components, and this will give you a list all the possible component types that you can create using ODO. So this is list of the components that's in the old style ODO. So that's what we have there right now. It's strictly OpenShift specific, and it uses S2I builder images that are available in the OpenShift cluster. What we are interested in right now, and what I want to show you, is the def file components. And you can see it in the table here. And those are what we are going to use right now. So I am going to use just the generic Maven one with my application. So now I know that I want to use Maven and it's available. I can do ODO component create. I want to create Maven component and I will call it backend. So what this is going to do is that it will should fetch the Maven def file from the def file registry, and it will place it, or it already placed it in the current directory. So if I check here, you can see that there is already def file. It's similar to what Elson showed you earlier. This one uses just one image, one container, and what's most important here is the def and build command, def run and the build command. So those commands define how application is going to be built and run. But if I don't, I didn't need to write this. It's already provided, so I don't have to worry about that. Now, when I have my component created from the previous step, I can do just ODO push. So what ODO push does is that it takes the def file description that we have here. It translates it into the Kubernetes resources. In this case, it will create the deployment and the service because there is an endpoint defined. And once that's created, it will upload source code from the current directory that was here, And after that is finished, or it was already finished, it's executing the dev build command as defined in the dev file. So in this case, it's executing Maven package. This might take a few seconds because it's also downloading all the Maven dependencies. And the audio will execute the def run command. In this case, it means that it will execute the jar in the cluster, and we will have our application running. So you might notice that we are actually not building the containers here. We are just uploading the source code into a container that's already running, and then building and starting application inside already running container. So this is great for quick iterative development, but it's not ideal for production runs. But right now we are concerned about quick development. So we can see that's done, and now we have our Spring Boot application running in the cluster. I'm not going to access it directly. Instead, I will actually use my front end to verify it's working properly. So here I have my my front-end application, Node.js application. I already have the dev file here. It's similar as before. It's interesting here to notice is that there are environment variables defined. So those are actually describing how my Node.js application is going to, where my Node.js application can find the backend one. I don't need to do anything else here. I will just run audio push, and it will do the same steps as before. It's already uploading the source code. Now it's running npm install and downloading all the dependencies, and then it will execute the def run command. So you might notice that once that's done, the application will be running in the container, in the cluster, but we won't have any easy way to access it. But we know that it's actually exporting or exposing, or it's actually listening or doing something on port 3000. So what we can do, and normally you would create something like ingress on Kubernetes or route on OpenShift to expose this port on some URL where you or your customers can access it. Audio is a really nice command for that. There is audio URL create. Automatically create the ingress for you. So you audio create or URL create the dashboard. I know that it's 3000. I will tell it which base domain to use. So for my cluster, this is going to be apps.demo cluster. Now you can see that it's creating that it's actually not created anything on the cluster yet. It just recorded the information that the URL should be created and in the local file. And now when I can run audio push, and it will create the URL for me. There's also a second option how I could do this, and if I could also use just audio URL create and provide now flag, and that would do the same thing but in one step. So now we can check this URL, and we can see my application is running. It's a really simple application. Just put name here, and it will greet you saying "Ahoy, Thomas." So now let's do something more interesting. We can try to change something in our backend. So instead of "Ahoy, Thomas," it says "Hello, Thomas," for example, or it says "Hello" to and the name. So let's check the source code. Or what I'm actually going to do first is I will show you audio watch command. So I execute that, and you can see that what audio watch is doing is that it's checking the current directory, and it's waiting for the files, for some file to change in the directory. And when it detects the change, it will automatically push the source code. So if I go to my source code, I change this to hello, save it. Don't do that right now. I hit the save, and now you can see, I can close this, that it noticed that the file changed, and it's automatically pushing the changes. So I could also I can use this for really quick testing to see my changes. I can just switch between my editor and between the browser and see changes happening without actually worrying about anything. So I can do audio, and it should say hello audio. So you can see that the change was there. Now I could just switch. I have still watch running there, so I could just switch to the editor, do another change, wait a few seconds, and then I can see the changes very quickly in my cluster happening almost instantly. Now, when we are done with that, we can use our audio delete to clean everything ourselves, and it will automatically delete everything that was created before. We can do the same here. Okay, and that's all for the demo. Now Elson will give you more insights on what are our future plans for audio.
Okay. What Thomas showed is just what we have currently implemented so far. We're definitely more than just that. So let's talk about what we are going to do later. So first of all, we are going to, the current audio is more for Kubernetes, generic Kubernetes CLI for developers. We want to make it to be able to run anywhere as well. So we're trying to expand the scope of the audio CLI itself to be able to run in the non-Kubernetes environments. For example, in the local Docker environment, we want to support that. So the next one is the current list of dev files, or the registry itself, is actually predefined in audio. What we want to be able to do is to allow user to configure their own private dev file registry, so that they can actually provide their list of components that they support themselves, or they can have some modified components that they want to provide by default, and then they will be able to add and remove repositories as part of the listing. So when you do audio catalog list, then we will be able to see all the private ones that you have created as well. And then add notification mechanism is more for IDE integration, because we see audio can be the base framework for any other IDEs for consuming it, so that you can use it for base engine for doing the build and run. There are other source projects like Cowin, the Eclipse Cowin, that is actually interested in doing the IDE integrations in there as well. So we want the audio CLI to be able to use it for generic Kubernetes scenarios, use it for local Docker kube, but it's also be the base engines for IDE to do the build and run as well. Okay, so those are all the things that we want to talk about. In case you're interested to find out more information, there are a couple of references that we put in here that you can actually find the main audio repo itself, definitely the first place that you want to visit. And then we've got the existing dev file registry that we have, and that you can actually see some samples on. You can actually try creating some of your samples as well. And then dev file to some of the newer specification that we're moving forward as well. Okay, thank you. Thank you for listening to these sessions. I hope you get some useful information out of these sessions for Odeo, and hopefully you'll find Odeo itself is actually a good generic Kubernetes CLI for you to do application development on your Kubernetes systems. Thank you.